Hello. Yes. We welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard, here. Yes, today we are looking at this question. It says that the diagram below shows the pendulum of mass 78 grams being held at a height of 1.5 meters. So this is the diagram, and the question says, calculate the gravitational potential energy of this pendulum. So they are looking for a gravitational potential energy given by this expression. Potential energy is equal to mgh. Now the question is, what do we know? We are looking for potential energy, which we don't know. But do we all know the mass? Yes, we have it. It is 78 grams. And we need to know that the SI unit for mass is kilograms. So we convert this one to kilograms. So it is 78 over 1000, giving you 0.078 kilograms. Okay. Then we look for this one. We know it's 9.8 meters per second squared. And the height is given. The height is 1.5 meters. So with this information, what do we do? We substitute. We have EP being equal to the mass, which is 0.078, times 9.8, which is a constant, times the height, which is 1.5. And we get, this is what we get in joules, 1.1466. So that's the potential energy of this pendulum. Then we come to this case. It reads, the pendulum is now released and it swings downwards, passing the lowest point B. That's the point. And the question says, calculate the velocity of the pendulum when it passes the lowest point. Lowest point implies that the pendulum has fallen. So this is similar to when an object is held upwards and it is released. So what do we do here? We have to know that mechanical energy is conserved. And what's the formula? The formula says Emec at the top is equal to Emec at the bottom. You have to remember that what you call Emec is the Ek top plus EP top, which is equal to Ek bottom plus EP bottom. So in this case, what do we do? We can expand. So kinetic energy is a half mv squared. But the velocity must be the velocity at the top. Meanwhile, potential energy is mgh, the height at the top. Yeah, this one giving you a half mv bottom squared plus mgh, but h is at the bottom. So next, we substitute with what we have. At the top, the object was held, so the velocity is 0. So we're going to have a half times the mass. Now we need to remember that the mass is 0.078 and the velocity is 0 squared. So here we substitute for 0.078 times 9.8 times height, and the height at the top is 1.5. Yeah, this one is equal to half times mass. And what's the mass? 0.078 times the velocity, which we are looking for. Okay, plus the mass, which is 0.078 times this constant gravitational force times the height. At the bottom, the height is 0. So from here, what do we get? Here we have a 0, and yeah, here we have this 1.466. This one's being equal to the half of that. Yeah, this one gives us this plus 0. So this is what we are having. And what do? We get VB squared. So we're going to say VB squared is equal to 1.466 over 0.039. Yeah, that is it. So from here, what do we know? This is what we know. We are going to have 29.4 from here being equal to VB squared. Next step is to find the square root of both sides. This one giving us 5.42 meters per second, which is equal to VB. Yeah, then we come to this question. It says that what is the mechanical energy when the pendulum is at 1 meter from the ground? Yeah, this is 1.5 meters. Suppose the pendulum falls to that height. What will be its mechanical energy? Yeah, it will be the same mechanical energy as the one it had when it was at the top. So the answer is 1.1466 joules. Yeah, why? The reason is that mechanical energy is conserved. Conserved means it's the same throughout. And with that, I would like to thank you for your time. Yeah, the channel is PSSB, Physical Sciences, Silver Bullet with me, Richard here. Yeah, we urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye-bye.